Timeless Concepts from Physics Helpline. This is a video tutorial series through which we will sharpen our problem solving skill. First, we will analyze the problem on hand to find the related concepts. Then using these, we will develop a method which will produce the solution. This will help the students aspiring to get into IIT to understand the much needed advanced theories and applications in physics. In this video tutorial, we will discuss a problem on the adiabatic process of a gas enclosed in a container. The question is as follows. A rectangular box has a partition which can slide without friction along the length of the box. Initially, each of the two chambers A and B has 1 mole of monoatomic ideal gas gamma is equal to 5/3 at pressure P, volume V and absolute temperature T. Now, chamber A is slowly heated by an electric heater. The walls of the box and the partition are thermally insulated. Heat loss through the lead wires of the heater is negligible. The gas in chamber A expands, pushing the partition until the final pressure in both the chambers becomes 243 P divided by 32. Find the final temperature of each chamber and the work done by the gas in B. Before proceeding to solve the problem, let us recall the related concepts. Avogadro's law. It states that at the same temperature and pressure, equal volumes of all gases contain equal number of molecules. Consider two gases having thermodynamic parameters P1, V1, T1, N1 and P2, V2, T2, N2. According to Avogadro's law, if three of these parameters are equal for two gases, then the fourth must also be equal for both. For 1 mole of an ideal gas, we have PV is equal to RT, which implies PV by T is equal to constant. Equations for an adiabatic process are given in equations 1, 2 and 3, and work done in an adiabatic process is given in equation 4. Now we are in a position to solve the problem in the question using these concepts. Given that P1 is equal to P2 is equal to 243 divided by 32 into P and gamma is equal to 5/3. To find V1 and V2, we proceed as follows. PV to the power gamma is equal to P2 V2 to the power gamma, which implies V2 by V is equal to P by P2 whole to the power 1 by gamma. Putting the values of P by P2 and 1 by gamma, we get V2 is equal to 8 by 27 into V. Now, V1 plus V2 is equal to 2V, which implies V1 is equal to 2V minus V2. Putting the value of V2 and simplifying, we get V1 is equal to 46 by 27 into V. To find T1 and T2, we proceed as follows. For gas A, PV by T is equal to P1 V1 by T1. This implies T1 is equal to P1 by P into V1 by V into T. Putting the values and simplifying, we get T1 is equal to 207 divided by 16 into T. Similarly, for gas B, T2 is equal to P2 by P into V2 by V into T. Putting the values and simplifying, we get T2 is equal to 9 by 4 into T. Also, work done by gas B is W is equal to PV minus P2 V2 divided by gamma minus 1. Putting the values and simplifying, we get W is equal to minus 15 divided by 8 into PV. The negative sign indicates that work is done on the gas. This completes the answers to the different parts of the question.